You are welcome to this lecture. In this lecture, we are going to take the questions and answers section also, and this will be part 3. So if you know you've not watched part 1, part 2, please make sure you watch them before coming to see the part 3 of this lecture. Now the question says, a straight ladder. Before we go into question, please make sure you subscribe to this channel, turn on the notification button, and also comment. If we make any error anywhere, please make sure you draw my attention to it. Are we getting it? Comment so that you'll be notified whenever we post a new video. Now the question says a straight ladder 16 meter long is placed against a vertical wall. Now let's say this is the base. If this is the base and then this is the wall. Now you were told that a straight ladder is placed against a vertical wall with its lower end 9 meters away from the wall. So let's say this is the ladder and this is the lower end. So the lower end is how many meters away? 9 meters away from the wall. So they are telling you the distance from this part to this part is what? 9 meters. Now, from the wall, how high up the wall does it reach? Now, a straight ladder 16 meters long is placed against a wall. So this is your 16 meters. Now they are asking you how high up the wall does it reach. Now this is where you are asked to find how high up the wall does it reach. What angle does the ladder make with the wall? Now if you are given anything like this, what do you normally do to solve your answer? What angle does the ladder make with the wall? It means they are asking you to find this angle here, theta. Then how high up? Of course, we know this is a right angle triangle, and we have the hypotenuse, opposite, and what? Of course, we have the adjacent. So in this case, what will be your solution? To get here, which is the adjacent, you know that hypotenuse squared is equals to opposite square plus what? Adjacent what? Squared. Now what are you looking for? You are looking for the adjacent. Hypotenuse is what? 16 meters. So you say 16 square. Opposite is 9 square plus adjacent is s square. And this will be equals to 16 square is what? We have 16 square is 256. So this gives us 256 is equal to 9 square is 81 plus s square. So to make s out of the formula, let 81 cross to this side of the equation. If 81 crosses to this side, we are going to have 256 minus 81, which is equals to s square. 256 minus 81 minus 81. Now 256 minus 81 is 175 is equals to s square. So your s square will be the square root of 175, and the square root of 175 is square root of these two. This cancels this. S will be equal to the square root of 175. Now square root of 175 is 13.322. So it has a height of 13.322. 13.3 or 13.222. 13.222 meter. It's as easy as that. Okay, it's as easy as that. Now the next thing they ask is the angle it makes. Now how do we calculate the angle? The angle is you take one of the sides that has the angle, and this side is opposite. Let's take opposite over hypotenuse. Opposite over hypotenuse. Opposite over hypotenuse. Now, which is the opposite now in this case? Is 9 meters. So we can say sine theta is equals to opposite over hypotenuse. Now, sine theta will be equals to, where's your opposite now in this case? It's 9 meters. So we say 9 Hypotenuse is what? 16. So we say 16. 9 divided by 16 is 0.56. So sine theta is equals to 0.5625. Now to get theta, say theta is the sine inverse of 0.5625. Sine inverse of 0.5625. And then the sine inverse of that will be what? So we have it as shift sine of the answer you got initially, which is 34.22 degree. So the angle is x, or the height is s, is 13.22 meter at an angle of 34.22 degree. It's as easy as that. It's an angle of 34.22 degree with the wall. Because they say, how high up the wall does it reach? When you say how high, it means they want to find the height that the disc made with the wall. And then what angle does the ladder make with the wall? This is a ladder. At what angle does it make with the wall, which is your theta? And that is how to solve a question like this. Now let's look at the next. Evaluate the following. Now, before you have an understanding of this, you have to note the 4 quadrants. Now the quadrant is represented with cast CA, then ST. Now what does this mean? Here means all trigonometry ratios are positive, all positive. That means sine is positive, cos is what? Positive, and what? Tan is positive. So in the first quadrant, all of them are positive. Now in the second quadrant, what is only positive? Only sine is positive. Now in this quadrant, it means only tan is what? Positive. Why in this quadrant, it means only cos is positive. Only cos is positive. Now, if you are looking from an angle here, you just punch it in your calculator the way it is, and you get your answer. Now, you can punch all of this into your calculator, you get your answer. But they expect you to show something, and that is what we are going to do now. Now, look at sine 135. Sine 135. Now, sine 135, it means if you have here, this is your 0, this is 90, this is 180, this is 180 plus 90 is 270, and this point against 360. That's moved 360 degree. Okay. Now, what this thing is trying to do, you are trying to get the angle here, because 135 will be between 90 and what? 180. 135 is between 90 and 180. So it is called obtuse angle. So, but the sign is positive there, so it will now be sine bracket 180 minus phi, where phi is the angle in question. Now the angle in question is what? 135. So this gives us sine 180 minus 135. Sine 180 minus 135, and that will give us, to get the angle, because this is what you are having now, to be from here to this point, which is 180. Are we getting it? Or to get the, what we are actually looking for is to get the angle at this particular point here. Okay, so to get that angle, it should be this 135, which we've already got, to minus 180 will give us the angle here that it made with the second quadrant. Are we getting it now? So that will be 180 minus 135 is 45 degree. 135 is 45 degree. So you now have sine 45 degree. And sine 45 degree is what? Sine 45, 0.7071. If you also press sine 135 in your calculator, it will also give you that answer. Are you getting it? So when you see things like this in the exam, you just have to punch your calculator, not undermining what you are going through. Now the next one is cos 150. Cos 150. Now cos 150 is in which of the quadrant? This is 0 to 90 is first quadrant. 90 to 180 second quadrant. 150 is in the second quadrant. I will say in the second quadrant, it's only what? S, which is sign that is positive. It means cos will be what? Negative. Are we getting it now? So it will be cos, to be minus cos. Then we also have 180 minus 150. Minus cos 180 minus 150. And this becomes minus cos what? 180 minus 150 is 30. Minus cos 30. Cos 30 is what? 0.8660. So this gives us minus 0.8660. If you punch this in your calculator, that's what it will give to you. Cos 150 will be minus 0.8660. That is why it is like this. Are you getting it? It's like we have what is called supplementary angle. That means the angle it will give in a particular quadrant. Now the next one is now for this of tan 210. Tan 210. Now tan is positive in the third quadrant. It's positive, and 210 is between 180 and 270. That is, it falls in between the third quadrant. So what are we going to do in this case? Now for tan, or for the third quadrant, this is how to get the supplementary angle. Is tan the phi minus 180. Tan phi minus 180. Now what do we have there? You have 210. So this becomes tan 210 minus 180. Note that it's positive, so we don't need to add negative there. And this becomes tan 210 minus 180 is what? 30. And then if you check your tan 30 with your calculator, it's going to give you, if you check it, it's going to give us 0.5773. And that is the solution to that question, 0.5773. So tan 210 is the same as tan 30, which is 0.5773. Sine 300. Now for 300, it's usually 360 minus 5. Usually 360 minus 5, which is sine 360 minus, what is your phi? Your phi is, okay, let's press tan 60. It's still the same thing it's given to me. $270 minus 210. Okay. 360 minus 300. But sine, on that, what quadrant are we talking about? Is the fourth quadrant. In the fourth quadrant, only cos is positive. So here will be what? Negative. Minus sine. 360 minus this is what? Is 60 degree. Okay. So sine 60 is what? 0.8660 minus, now become minus 0.8660. So that is the answer to that question. Now, for this particular thing, you may not understand it until you take trigonometry very well. But for the sake of the assignment, you may just want to write. Then when we take trigonometry proper, you may understand it better. Now, the next one you have is cos 330. Now, cos, is it positive? 330 is in what quadrant? From 270 to 360 is fourth quadrant. So 330 is the fourth quadrant. So this gives us cos, and the quadrant is usually 360 minus phi. Okay? Which should now be cos 360 minus, what is your phi? 330 is positive. And this will be cos 360 minus 330 is 30. Cos 30 is 0.8660. So it is positive, so we don't need to add negative. So cos 330, 0.8660. So this is what you are expected to do in this case, not just punch calculator. Now, I believe this one for the tan, maybe there is an obvious error somewhere, or let's press tan most of be 270 minus 210 to get the angle it made with that place. 270 minus 210 cos 210 0.5 then tan. Okay, let's leave that for now. I'll make research on that and then correct if there's any correction to be made. So that is the solution to that question. Now let's look at this one. Say prove that 1 minus tan square x, 1 minus tan square s all over 1 plus tan square s is equals to cos 2x. If you are asked to prove that this is equals to this. Now note, like I told you, you have to take a course on trigonometry in order to understand this better. But for the sake of this assignment, we just have to copy. Now this cos what? 2x. Note that cos 2x is the same as 1 minus sine square s. 1 minus 2 sine square s rather. Or 1 minus sine square s. When we get there, like I told you, I don't cram. When we get there, we'll know if it is, okay, this is supposed to be 2 sine square s. Let's solve now. How do we get to this point? Now, note that from trigonometry identity, that tan s is the same thing as sine s all over cos s. So wherever we see tan s, we put sine s over cos s. And this gives us 1 minus, in place of tan square s, we put sine square s all over cos square s, divided by 1 plus what? Sine square s all over cos square s. Now, what are we going to have here? You have 1 minus sine square s all over cos square s. Why? Because sine square s over cos square s will give us tan square s. Now, this all over 1 divided by 1 all over 1 minus what? Plus sine square s all over cos square s. So what do we do at this point in time? What do we do? We can say, so we are to prove that this is equal to cos 2x. Now, what is the LCM here? The LCM here is cos square s. So we have cos square s all over cos square s divided by this will give us cos square s divided by this will give us cos square s, then times 1 will give us another cos square s, minus cos square s divided by this will give us 1. 1 times sine square s will give us what? Sine square s. Okay? Divided by this cos square s also as the base. Cos square s divided by this will give us cos square s, then plus this times this will give us what? Sine square s. Now, at the end of the day, you discover that we have something, which is we have cos square s minus sine square s divided by cos square s divided. This big division here, we can put it as divided. Now, note, cos square s plus sine square s is equals to 1 from the identity that says sine square s plus cos square s is equals to 1. So everything here on top here can be 1. So we have 1 all over cos square s. Now, at the end of the day, you now have cos square s minus sine square x. Then you have divided by cos square s times this will come up cos square s all over 1. Cos square cancels cos square s. We are left with cos square s minus sine square s. Are you getting it? Now we want to prove that this is equals to cos 2s. And of course, it's true. Cos 2s is what? Cos square s minus sine square s. But how do we prove that? Note that I told you earlier, let's go to a fresh sheet. Cos square s minus sine square s is equals to cos 2s is equals to cos 2s. Okay, that's what we have, cos 2s. Note that we earlier said that sine square s plus cos square s is equals to 1. If it's equals to 1, then we can make cos subject to the formula, and this one cos to this side. So cos square s will be equals to what? 1 minus sine square s. So in place of cos square s, we can put 1 minus sine square s, right? This will now become 1 minus sine square s minus, we substituted it here now, minus what? Then we now have sine square s, and everything will give us what? Cos 2s. Now this become 1 minus this is what? 2 sine square s, which equals to cos square s. And initially, note that I said 1 minus 2 sine square s is the same thing as what? This is not cos square s, this is cos 2s. It's the same thing as cos 2s. So cos 2s is equals to cos 2s. So you successfully prove. If you saw when I started, I said cos 2s is 1 minus 2 sine square s. So you come here, say 1 minus 2 sine square s equals to cos 2s. So cos 2s is equals to what? Cos 2s. So you've proved that this whole nigger here is equals to what? Cos 2s, following all these approaches. Now let's look at the next question. The next question says, given that the universal set, now the universal set given to you is s is greater than or equal to 0. Now s is greater than or equal to 0, it means you start from 0, but it's less than or equal to 10, means 0 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And a is 1, 3, 6, 9. And then b is 0, 2, 4, 9. The question says find a prime intersection b. Now what is a prime? A prime means the universal set minus a. A prime means what? Universal set minus a. So we are now going to write it out. A prime will be equals to universal set is 1 to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Minus a is what? 1, 3, 6, 9. And then when you subtract the 2, this one is gone, nigger, 6 gone, then 9 gone. So what are we left with? Our a prime is equal to, let me write it upward here. A prime is equals to 0, 2, 4, 5, 5, 7, 8, and 10. Then b is what? 0, 2, 4, 9. Now a prime intersection b means what is common between a prime and b. What is common between a prime and b? What is common here? 0 is common, so you take it. 2 is common, so you take it. 4 is common, so you take it. What other thing again? Nothing. So the correct answer is 0, 2, and 4. Now the next question says find a. Then we have symmetric product a and b and b and a. Now note that a and b is the same thing as b with the symmetric product of what? A. So anything you have here, a symmetric product of b must be equals to b the symmetric product of a. Now the question is, what is the symmetric product? Now symmetric product a and b is given by the expression. Is given by a minus b union b minus a. Or in a short term, you can take it that all the elements in A and all the elements in B, but not anything they have in common. So what are the elements in A? A is 1369. A is what? 1369. So we say A is equals to 1369. And B is 0249. 0249. So what we are going to do now is very easy. Let's find A union B, or A minus B first. A minus B is what? Subtract everything that is in A, or everything that is in A but not that is in B, that is also in A. Subtract them, remove them from the equation. So A minus B will be A is what? 1369 bracket minus B is what? 0249. So what are those things present? 9 and 9 is out. What other thing again? That is the only thing. So A minus B is equals to, you are now going to write only this 1, 3, and 6. That is A minus B. Now B minus A means anything that is in A that is also in B, remove it. Anything that is A that is also in B, remove it. That is the meaning. So you have B is what? 0249. Anything that is in A that is also in B, remove it. So this gives us 1, 3, 6, and 9. So what are we going to do now? Remove the 9 too. So what are we left with? We are left with 0, 2, 4. Is there any other thing? No. So B minus A is 0, 2, and 4. So we say our A minus B is 1, 3, and 6. And B minus A is 0, 2, and 4. So the union of A minus B, union B minus A, will be equals to, write everything here without repetition. So this becomes 0, 1, 2, 3, 4, and what? 6. So our A, the symmetric product of A and B, will be equal to 0, 1, 2, 3, 4, and what? 6. 0, 1, 2, 3, 4, and 6. Are you getting it now? 0, 1, 2, 3, 4, and 6. Is that clear? So that is the symmetric product. Now that is still the same thing as B. The symmetric product of B and A, same as 0, 1, 2, 3, and 4, then what? 6. Because this ones is the property, commutative property, that says that A, the symmetric product of A and B, is the same as the symmetric product of B and what? A. And that answers that question. It's very simple. All you just need to do, A, the symmetric product of A and B is A minus B union B minus A. Now, if you want to do it without even this thing, all you just need to do is write what is in A and what is in B, and then anything that is common between A and B, don't write it. That is the answer. Write anything that is in A and is in B, but anything common between both of them, don't include it. So this is A, symmetric product of A and B will be equals to, what do we have here? 0. Is there any, is 0 here? No. So you take it out as 0. What do we have here? 1. Is 1 here between the both of them? No. So you take it as 1. What do we have here? 2. Is 2 common? No. So you take it down. The next one is 3. Is 3 common between them? No. So you take it down. Then what do we have here? 4. Is 4 common? No. Then we have 6. Is 6 common? No. But we have 9. But 9 is common between the both of them. So you don't write it. So the answer is what? 0, 1, 2, 3, 4, and 6. And that's what we have here also. 0, 1, 2, 3, 4, and 6. And that is the answer to that question. Now you have the following. We are asked to express them in the form of A plus B. You have the following. You are asked to express them in the form of A plus B. Now, how do you do it? Express them in this form, A plus BI. Add the real part and the imaginary parts. Add the real part and the real part of one, and the imaginary part of another. So we have 2 plus 4i. and then 5 minus 2i. If you add these two, now 5 plus 2 is what? 7. Then plus 4i minus 2i will give us what? Minus 2i. So the correct answer to this question is 7 minus 2i. It's as easy as that. 7 minus 2i. Now this one say multiply. You are going to use this one to open through the bracket. So you have 4 plus 3i brackets 2 plus 6i. This times this is 8. 4 times 6i is 24 iota. Plus 3 iota plus 2 iota is what? 6 iota. Plus 3 iota plus 6 iota is what? 18 iota square. And this becomes 8 plus 24 iota plus 6 iota is 30 iota. Plus 18 iota square. I told you iota square is what? Minus 1. Iota is root minus 1. Iota square is root minus 1 square, which is what? Minus 1. So this gives us 8 plus 30i. 18 times minus 1 is minus 18. Now, this becomes 8 minus 18 plus 30i. And this gives us minus 8. 8 minus 18 is minus 10 plus 30i. And that is the solution to that. So let's take the next one. The next one is somehow very crucial to our understanding of this stuff. And I've done something like this before. Told you that whenever you have something like this, it's going to give us 2 plus 3i divided by 3 plus 2i. Are we getting it? Now, for you to express this in this form, you must rationalize. When I say rationalize, it means rationalize, divide both up and down by the conjugate of what you have here. So this becomes 3 minus the conjugate of this. I told you that the conjugate of the denominator is just what you have by multiplying that by this, and this gives us 3 minus 2i, not multiplying, rather by changing the sign in between. I don't know what is popping this up, and this gives us 2. That gives us 2 plus, there we have 3i. Let me explain this again in a fresh sheet so that you have an understanding of it. Now the question says, if you have 2 plus 3i, 2 plus 3i divided by 3 plus 2i. I believe that was what it said. 2 plus 3i divided by 3 plus 2i. Now what you do is rationalize both up and down. When you say rationalize, it means multiply up and down by the conjugate of this, of the denominator. Now the denominator is what? 3 plus 2i. What is the conjugate of 3 plus 2i? The conjugate is 3 minus 2i. So you come here, multiply both up and down by 3 minus 2i divided by 3 minus 2i. So multiply both up and multiply both down. So this gives us 3 plus 2i bracket 3 minus 2i bracket close all over 3 plus 2i bracket and 3 minus 2i. Now 2 times 3 is what? 6 plus 2 times minus 2i is minus 4i. 3 times 3 is 9i. Then 3i times minus 2i is minus 6i square. All over 3 times 3 is 9. 3 times minus 2i is minus 6i plus 2i times 3 is 6i. Then minus 4i square. And this becomes 6 minus 4i plus I, 9i is what? Plus 5i. Then minus 6i square. All over 9. This times this minus 6i plus 6i will give us 0. So you have minus 4i square. Now, we know that I square is usually minus 1. So this gives us 6 plus 5I minus 6 bracket minus 1 divided by 9 minus 4 bracket minus 1. And this gives us 6 plus 5I plus 6 divided by 9 plus 13. 6 plus 6 is what? 12 plus 5I, this plus 4, rather minus 4 times minus 1 is 4 divided by 13. So at the end of the day, if you spread this 13 under them, you have 12 divided by 13 plus 5I divided by 13. And this is the solution to your question. Are we getting it? You don't need to find the conjugate. They just say they express it in the form of A plus IB in such a way that you have the real part. The real part is 12 over 13 and the imaginary part, which is 5I over 13. And that is the solution to that question. Now let's look at the next one. The next one says 5 bracket 1 plus I. This one is also humongous. Let's take it. Okay. 5 bracket I, 1 plus I, then squared. 5 bracket 1 plus I squared. 5 bracket 1 plus I, then all over 1 plus I, 1 plus 3I, 1 plus 3I, then everything is what? Squared. Now, if you have anything like this, the first thing you do is use the 5 to expand the bracket. So this gives us 5 plus 5I divided by 1 plus 3I. Now you have this. This is what? Squared. So at this point in time, you don't need to rationalize first. First of all, you have to multiply this by this again because it's squared. So this gives us 5 plus 5I divided by 1 plus 3I bracket 5 plus 5I divided by 1 plus 3I. Now 5 times 5 is 25 plus 5 times 5I is 25I. 5 times 5I is another 25I. 5I times 5I is plus what? 25I squared. Divided by 1 plus 1 is 1. 1 plus 3I is 3I. This times this is 3I. Plus 3I plus 3I is what? 9I squared. And this will be 25 plus 50I plus 21, plus 25I squared. And this all over. Why? Because 25I plus 25I will give us what? 50I. Then we have 25I squared. Then all over 1 plus 3I plus 3I will give us what? 6I plus 9I squared. Okay? Now this becomes 25 plus 50I plus 25I squared means what? 25 bracket minus 1, because we said I squared is minus 1, all over 1 plus 6I plus 9I squared is 9 bracket minus 1. And this becomes 25 plus 50I minus 25 all over 1 plus 6I minus 9. 25 we cancel 25, so we are left with 50I all over 1 minus 9 is what? 8 minus 8 plus 6I. Now at this point in time, now you cannot rationalize because it can't be in this form. Now how do we rationalize? We say we rationalize by multiplying both up and down by the conjugate of the denominator. So we have 6I times minus 8 minus 6I minus 8 minus 6I. Multiply both up and down by the conjugate of the denominator. Conjugate of the denominator is just by changing this sign here to a different sign. So if it were negative, change to positive. If it were positive, change to what? Negative. Multiply both up and down by it. So this multiply by this. it gives you 50 brackets minus 8 minus 6i divided by minus 8 plus 6i bracket minus 8 minus 6i. Now 50 times this will give us minus 400 minus 300i multiplied by minus 8 is 64. Minus 8 times this is plus 48i. 6i times this is minus 48i. 6 times 6 is minus 36i squared. And this gives us minus 400 minus 300i divided by 64. This cancel this gives us 0 minus 36i squared. This becomes minus 400 minus 300i divided by 64 minus 36i squared means what? 36 minus 1. Are we getting it? Now 36 minus 1 times this will give us plus what? 36. And this becomes minus 400 minus 300i divided by 64 plus 36 is what? 100. And at the end of the day, I was thinking, okay, let's come here. Please take note that we wrote it here. At the end of the day, what are we going to have? We have minus 400 minus 300i divided by 100. Now, what is common here? 100 is common. So if 100 comes out, it becomes minus 4 minus 3i. Are you getting it? Minus 4 minus 3i. Then brackets. Minus 4 minus 3i bracket. We are supposed to have something here. Oh, sorry about that. Sorry about that. You're supposed to be 50i. So if here is 50i, it means here will be 400i. And here will be what? 300i square. Here will be 400i. Let me write it again. Here will be 400i, and here will be 300. I square is what? Minus 1. And here becomes minus 1 times 300. Minus 300 becomes plus 300. And then we have 400i here. So here become minus 400i. So please take note of that. Minus 400i. So what we are supposed to have here is minus 400i plus 300. Okay? So here become minus 400i plus 300. Now when you do this, everything all over 100. So what is inside here? We see change to minus 4i plus 3. 100 cancels 100. And then your final answer is minus 4i plus 3. And that is the solution to this question. So the solution to this present question here is minus 4i plus 3. Or you can write it as 3 minus 4i. Minus 4i plus 3 or 3 minus 4i. Now let's look at the next question. The next question says resolve this into partial fraction. Now to resolve anything into partial fraction, what do? We have 3s minus 1 all over s plus 1 squared. Resolve into partial fraction. What you do is a all over, since this one is repeated, you write this one first, s plus 1, then plus b all over s plus 1 squared. Now, what are we going to have here? We need to find the value of a and b. So this becomes s plus 1 squared is equal to, the reason why we did it like this is repeated factor. Are we getting it now? You first of all put s plus 1, then s plus 1 squared. Now, if it were to be s plus 1 raised to the power of 3, what will it be going to be? S plus 1 under, that is a all over s plus 1 plus what? B all over s plus 1 squared plus c all over what? S plus 1 raised to the power of 3. So you'll be writing it until you get to the power that you have there, the highest power you have there. So this one now ended the square. So that was the reason why we ended there in square. Okay. Now, this will be equals to A all over S plus 1 plus B all over S plus 1 squared. Now, what is the LCM of this and this? We have 3x minus 1 divided by S plus 1 squared. Where is the LCM? The LCM here is S plus 1 squared. Because S plus 1 squared can go into S plus 1. It can also go into S plus 1 squared here. So S plus 1 squared going into this. Of course, you know square means you are writing this twice. So when it goes to this one divide one of the square here. Here we have A bracket what? S plus 1. Plus when this divide is, it gives you 1. 1 times B is what? B. Now at this point in time, these bases are equal, so they can cancel out. So what are we left? We are left with 3x minus 1 is equal to A bracket S plus 1 plus B. Okay? Now, at this point in time now, what are we going to do? To get our B, you now say 3x minus 1 is equal to A bracket S plus 1 plus B. To get our B, let's eliminate A. To eliminate A, say let S plus 1 be equals to 0. Because if S plus 1 is equals to 0, it means everything here will be 0. And 0 times A will be what? 0. So S will be equals to what? Minus 1. So it means that for us to get S plus 1 equals to 0, it means we should substitute S is equals to minus 1 into this equation. So this gives us 3x. Substitute that into the equation. In place of S, we put minus 1. So become 3 bracket minus 1 is equal to A bracket minus 1 plus B. And this becomes 3 minus 1 is minus 4, minus 3 rather. So this gives us minus 3 minus 1 is equals to A minus 1 minus 1 plus 1 is 0. Minus 1 plus 1 is 0 plus B. And it becomes minus 3 minus 1 is minus 4 is equals to 0 plus B. And then your B is equals to minus 4. So your B is equals to minus 4. Now, if your B is equals to minus 4, it means in order for us to get A, we can do something. First of all, let's take this one out. 3s minus 1 is equals to A bracket S plus 1 plus B. Now, what do? Use this A to open through. So this gives us 3s minus 1 is equals to this multiplied by this is AS plus A plus what? B. Now, if you compare both sides of the equation, what are you going to do? The one that have S equates them. Why the one that don't have S equates them? So if I may write this again in the other part of the board, we have 3x minus 1 is equals to A bracket S plus 1 then plus what? B. Then also, believe that what we have here. So this now, I told you, if you use this A to open through, you have minus 1 equals to AS plus what? B. Plus A plus B. That equates. Let the AS, the one that carry S, equate them. So this gives us 3S is equals to what? AS. AS is the one that carry S here. So equate it with this. When this cancels this, your A is equals to what? 3. Or you can decide to say, let the other one, which is the one that don't carry S, which is minus 1, will be equals to A plus B. And if minus 1 is equals to A plus B, minus 1 equals to, your B is what? Your B is plus 3. So when 3 comes to this side, sorry, your B is 4, minus 4. Your B is minus 4. So this becomes minus 4. Minus 1 will be equals to A minus 4. And when minus 4 crosses to this side, become minus 1 plus 4 is equals to A. And your A is equals to 3. So you can get A in two ways. So in this case now, our A is 3. And our B is what? 4. Minus 4. A is 3 and our B is minus 4. Now, initially you said 3s. We said 3s minus 1 all over s plus 1 square is equals to A all over s plus 1 plus B all over s plus 1 squared. So you've calculated your A and B now. So what will be your answer now? 3s minus 1 all over S plus 1 squared is equal to, in place of A, you put 3, S plus 1, then in place of B, you put minus 4, S plus 1 squared. And that is the solution to that question. Okay? Solution to that question. Now let's look at, I believe we should end it here today. So we are going to end it here today. Thank you for your time. It was really a long journey today. Thank you for your time. Okay? Make sure you subscribe to this channel. Turn on the notification button so that you'll be notified whenever we post a new video. Thank you. Thank you. Thank you. Bye-bye.